What's up, everybody? Mr. Jones back here with you, and we're still going to be talking a little bit about this quadratic formula, okay? But we're going to be talking about just a specific part of it, okay? So we're going to be talking here about discriminants, and you notice the discriminant is equal to b squared minus 4ac. And you notice within your quadratic formula, that is the specific part of it that is within this square root, right? So this is the expression that we would take the square root of, right? And again, you should already know this, but the a, b, and c values in here come from the a, b, and c values within a quadratic equation, right? They would be my coefficients, okay? So there's three different possibilities here, right? So if we evaluate just this expression and it results in a positive number, okay? So this would be after we substitute in all these values into the expression here, and it results in a positive, there's going to be two solutions. And I'll explain why that is in a second, okay? So if it's a positive answer, there's going to be two solutions. There's also a situation where you could get zero. If you substitute in all these values and you would get zero out of this, there would be just one solution. There would be just one solution, and then there's a third possibility. You could probably see a pattern here. If it is a negative, okay, if this discriminant, if this expression ends up resulting in a negative value, there would be no solutions, or we could say no real solutions. Why does that happen? Well, you notice that this is, right, this expression, we're taking the square root of it, right? We're taking the square root of this, and then that value is, right, it's the quadratic formula says the opposite of b plus or minus the square root of that, right? So if we take the square root of that and we get a single number, right, there's three possibilities. And again, if we think of our rules with square roots, right, we can take the square root of a positive number and that's fine. Okay, sometimes we'll end up with a decimal. Sometimes if it's a perfect square, we'll end up with a whole number, but we can take the square root of a positive number, it's fine. Okay, if we take the square root of zero, it would just be zero, right? And the reason this would end up with one solution is, right, let's just say the b value is 2. Okay, so if it'd be negative 2 plus or minus 0 over 2, right? If you would, on the top of the fraction here, if we had 2 plus or minus 0, whether we added or subtracted 0, that wouldn't really matter, okay? So in this instance, there would just be a single answer of negative 1, right? And that's it. So if that discriminant, or if that square root ends up equaling 0, then there would just be one solution, okay? That happens sometimes. Again, this is the most common. This happens sometimes. And then this also happens sometimes, okay? If this ends up being a negative, if this discriminant ends up being a negative, there's going to be no solutions, okay? Because, again, if you think about taking the square root of a negative number, like if I asked you, what's the square root of negative 16, right? You would be answering what number times itself equals negative 16. And you couldn't really give an answer to that, or at least whole numbers, right? Or real numbers, because you can't do something times itself to equal a negative answer, okay? So that would be, right, so once we get to that point, and we saw that in an example I did in the quadratic formula video. If there's a negative in the square root, you couldn't move forward. There would be no real solutions. So those are the three situations, okay? Probably, again, most common, and these two both happen sometimes as well. But so what we're going to do here, we're going to just look at a few examples of quadratic equations, and we're not going to solve it out with the whole quadratic formula, but we're just going to answer, okay, how many solutions will it have? Okay, because sometimes you're asked about that too. So let me erase this and we'll do that. Okay, so if we're asked to find how many real solutions each quadratic equation will have, again, we don't have to factor the whole thing and find the exact answers. We don't have to do the whole quadratic formula. We can, if we're just wondering how many solutions there will be, not necessarily wondering what the solutions themselves are going to be, we can just perform the discriminant, right? We can evaluate the discriminant, and if depending on what sign it is, we can answer the question. Okay. So if I look at the first one, 3x squared minus x minus 7, again, first step would be to figure out what are my a, b, and c values. So a is 3, b is negative 1, C is -7, okay? And I lied, the first actual step should be to make sure that, like we said before, that it says equals 0, okay? That all the terms are on the same side and the other side says equals 0, okay? So this one was already good, but the other ones we're gonna have to do some work first. Okay, and then I plug those in, right? Because my discriminant, b squared minus 4ac, I'm going to substitute these values into there. So it's going to be -1 squared minus 4 times 3 times -7, okay? And so if I do -1 squared, that would be 1, okay? Minus 4 times 3 is 12. 12 times 7 is going to give me 84. But keep in mind, -4 times 3 times -7, right? We have a negative times a negative, okay? So that's going to end up being positive 84, which will give me a positive 85. And it doesn't matter what the number is, okay? If it's any positive number from this discriminant, okay, we are going to say, okay, if it's positive at all, yeah, we know there's going to be 2 solutions. So that's for number 1. There would be 2 solutions to that, okay? So that's for that first one. The second one, again, our first check is, are all the terms on the same side? And no, they're not in this one, right? It does not say equals 0. So the easiest thing to do here would be to just add this 5x to both sides, okay? So I do that, and I'm left with -x squared. I'm going to sneak that in the middle here, plus 5x plus 8 equals 0, okay? And then again, I write out what my 3 a, b, and c values are. So a is -1, b is +5, and c would be +8, okay? So then I substitute all these in here. So it would be 5 squared minus 4 times -1 times 8, okay? So then I do, so it would be 5 squared would be 25 minus 4, so it would be -4 times -1, so that would be +4, then +4 times 8 would be 32. So you could say 25 plus 32 or minus negative, but that's the same thing. So 25 plus 32 gives me 57, and again, it doesn't matter. So this would also have 2 solutions. So there is that one. All right, so if I then look at number 3, does it say equals 0? No, so I have to take care of that. I'm going to plus this 2 to both sides. Easy to get that over to the other side. So 0 on one side, other side 2x squared plus 4x plus 2, okay? And then again, a, b, and c values, a would be 2, b would be 4, c would be negative or positive 2, okay? Substitute all those in, so I would get 4 squared minus 4 times 2 times 2, okay? And so then I evaluate 4 squared would be 16, and then that'd be 16, and then 4 times 2 times 2, well, 4 times 2 is 8, 8 times 2 is 16, so it'd be 16 minus 16, which is 0, okay? So again, if that discriminant's 0, that means that there is one solution, all right? Because we would take the square root of that, and it would be 0, and that plus minus wouldn't really apply anymore. We wouldn't have to worry about that, okay? Last one here. Now this one's weird because, let me switch colors. Yeah, this one's weird because the x squared term's on the right here. Usually it's not like that. But again, our goal, it doesn't matter which side says equals 0, just as long as one of them does. So it would be easier for me to just plus this 10 to both sides, okay? So I'm there, and it says 0 equals 9x squared plus 17x plus 10. Okay, some bigger numbers here. And so again, a value would be 9. Again, it says equals 0 on the left now, but again, it doesn't matter. We're still focusing on this trinomial here. So a squared is 9, or a is 9, b is 17, c is 10. Okay, all positive. And so from here, I'm going to, again, plug into my discriminant, okay? So that would be 17 squared minus 4 times 9 times 10, okay? And then you evaluate, right? So 17 squared, wonder how many people know that off the top of their head. 17 squared, it is 289, 289. So then 289 minus 4 times 9 is 36. 36 times 10 would be 360. 360. Okay, so then we subtract 289 minus 360 gives you a whopping negative 71. And negative 71 is negative, indeed. So there would be no real solutions here. No real solutions, okay? And I keep saying real here. Usually we would just say no solution, but we are pretty soon going to learn what imaginary numbers are. And that's going to allow us to deal with some negatives in here. But we'll get to that later. But I just wanted to go over that discriminant with you because, again, it's a little bit less work for you to do if you're just asked for the number of solutions to just evaluate that discriminant, okay? So thanks for following.